For me, robotics is about figuring out how to build machines that are going to enable people to interact with the world, much more effectively through machines, through avatars, in ways that just weren't possible previously.
212 is introduction to robotics. How do we get machines to move in a certain way, move to certain locations, configurations, or generating specific forces in their environment?
Today is Tuesday, so the competition is in 2 days. The robots now should be capable of driving autonomously to the points on the board. Most of the mechanical stuff should be built.
This year, the competition is called Pokemon Robotics Challenge.
The task is to design a machine that is capable of locating Pokemons in their environment and then catch them and put them in storage. They need to design an arm that is going to grab these Pokemons.
This is just a set of grippers. They're made of acrylic, and it's mated to these gears that, when they open and close, also actuate the mandibles as well to open and close. So you can go and grab things.
All of this involves this autonomous navigation, avoiding obstacles, and then using vision to identify, where they are, and then position the robot in an appropriate way in front of these bins.
The thing that seems to be happening right now is just kind of jiggling back and forth. That's because it's trying to get to a point, but the accuracy of the encoders is kind of off. So it kind of overshoots and undershoots. It uses kind of a filter of all this data to figure out where it's located. The only problem is it's very jumpy because it has so many different data points that it's just trying to smooth everything out and it's not quite there.
We've added April tags. These are like landmarks because those are at very, very specific locations. They know the coordinates of those tags.
It helps robots to orient itself. When it sees one, it does some kind of calculation, and then it will know where exactly it is based on its view angle of this April tag, as well as the April tag's position, which is known.
When the camera sees these tags, since the Kinect has a depth sensor, it can figure out how far am I from a tag. And if you know how far you are from a tag, you can figure out how far you are from the reference point. This is the reference point right here. So we're referring to the bottom left corner of the arena. And so this April tag 0 right here is this tag on the screen. So if I put this in front of the camera, you'll notice that it's kind of showing that there's a robot right in front of that tag, it's looking straight at the tag.
Right now we're working on the mechanical assembly, so ours relies on a sweeper and a basket. If we need more springs than this, we'll find a way. We're trying to collect all the Pokemon on our basket, and at the very end, this rack will move up, and then we'll swing right down and let everything out.
The sweeper is supposed to just go to the Pokemon and sweep it back and push it onto a platform. And then after we collect all of the Pokemon on the platform, we're going to have another mechanism that raises it. And while raising it, the platform's going to tilt and everything's going to slide into the basket, or so we hope, with a lot of luck.
A lot of other designs rely on a mechanical gripper, and we're trying to alleviate some errors in terms of where the gripper moves to.
Everyone comes up with a different strategy. That's part of the beauty of the design process.
There's really no substitute for a well-tested robot, so the more time that they can put on the ground, I think the better off their team will be.
Our navigation and trajectory planning were all done within maybe the past 2 or 3 days. As competition day is coming, I feel like everything's actually falling together rather than falling apart.
This is it, right? This is the moment that we've been waiting for.
This is the competition for 212, but I really see it as a celebration. The students have worked very, very hard for more than 10 weeks, to get to where they are today.
It's off to a great start. Currently using both odometry and April tags to navigate.
Unfortunately, we lost about half our code around like 1 a.m. last night. So it was kind of a sad letdown. So we decided to stay up and pull an all-nighter trying to figure it out.
It tries to go to a waypoint that's slightly in front of this April tag and then basically checks to see how well it does. And based on the error in the horizontal position, it moves the arm and tries to grasp the Pidgey, which it did successfully.
And now the arm should deploy and release Pikachu into the tote.
This challenge itself is actually, we set the bar really high. It's not like some mediocre job to ask the robots to do.
Just kind of go for it. He is close. He might get it. Come on, Speedy. Oh! So he's got the right idea. He knows where he's going, but sometimes he's a little clumsy with his reach.
Does it sense whether it has it or not, ever?
Doesn't, no. We don't have any force sensors on there, so he does the same thing regardless.
Thinks it has it.
This one's tough to watch right there. What could have been?
Many students say it's a very fun process because we are teaching the state-of-the-art of the industrial framework. So that's not only fun, but also very useful if they want to develop robots for real world.
I don't know why the April tags are so small, and everyone complained that they're very noisy. But despite that, the one team did it a very reliable job. So this award and navigation is going to Team Charizard. Come over here.
All right.
It went a lot better than we thought it was going to. Our robot definitely had its best day today.